video and see if we can find more properties of inequalities.
Hey, here comes the twins. Maybe they can help. You guys look funny. Ha! I know. Hi, Jonald. Hi, Joey. Would you like to join us? Sure. I thought I'd never get down. Help! Ha!
Would you say that the twins, Jonald and Joey, have approximately the same weight?
Yes!
They're identical after all. Now, did the orientation of the seesaw change when the twins were each added on both sides?
No, ma'am. The heavier side was still heavier.
That's correct, Gabes. The same thing occurs with numbers. Let's consider two numbers, A and B, on the number line. Note that A is less than B. Now let's add the same value C to both A and B. Let C be equal to 2.
I'll do it. If we let C be equal to 2, then A plus C, or negative 2 plus 2, which is equal to 0, will be here. While B plus C, or 1 plus 2, which is equal to 3, will be here. Oh, A plus C is less than B plus C, since 0 is less than 3. Ma'am?
Do you mean if we add the same value to an inequality, the order of the inequality will remain the same?
What do you think?
I'm not sure.
Let's try another one. Consider 5 as 3. Note that 5 is greater than 3. Now what will happen if we add 4 to each side?
Let me do it, ma'am. 5 plus 4 is 9. And 3 plus 4 is 7. 9 is greater than 7. The order remained the same. It's just like the picture we saw.
Before the twins were added, the seesaw dropped towards the heavier side. After the twins were added, one on each side, the seesaw's orientation remained the same.
You're correct, Christine. But what do you think will happen if the twins got off the seesaw?
The orientation of the seesaw will remain the same.
Ma'am, do you mean if we add or subtract the same value from an inequality, the order of the inequality will remain the same?
Well, we know that it works with addition. Let's find out if it works with subtraction. Let's consider the same two numbers A and B, where A is negative 2 and B is 1. Let's now subtract C from A and B, where C is equal to 2. Where are A minus C and B minus C on the number line?
I'll do it. If we let C be equal to 2, then A minus C, which is negative 2, minus 2 will be negative 4. B minus C, which is 1 minus 2, will be negative 1. Hey, you're right, Gabez. The order remained the same. A minus C, which is negative 4, is still less than B minus C, which is negative 1.
Now remember, A minus C is just the same as A plus negative C. So 18 minus 4 and 10 minus 4 can be written respectively as 18 plus negative 4 and 10 plus negative 4. So we can say that if we add the same value to an inequality, whether it is negative or positive, the inequality will remain the same. This is the addition property of inequality. This property states that given any three real numbers, A, B, and C, if A is less than B, A plus C will still be less than B plus C. The same thing happens when A is greater than B.
Ma'am, I'm still a bit confused about this property.
That's okay, Christine. I'm sure some of your classmates feel the same way. Give me any two real numbers.
How about 3 and 5?
Okay, is 3 less than or greater than 5?
It's less than.
Now think of a number we can add to both 3 and 5.
Ma'am, how about 5?
That's good. So what is 3 plus 5?
8.
Correct. And what is 5 plus 5?
10.
Excellent. Is 8 less than or greater than 10?
8 is less than 10.
Let's think of another number to add to 3 and 5.
Ma'am, how about negative 3?
Okay, so let's add negative 3 to each side of the inequality. What will happen?
The left side will become 0 and the right side will become 2. 0 is less than 2. The inequality remained the same. Now I get it.
I'm glad.